Hi, everyone. Good morning, good afternoon, good evening, wherever the location that you're joining in. The session we are going to talk about how can we get a single pane of view of all the telemetry data that collected in the enterprise digital landscape. How can we get a unified view of all the entire IT landscape so that we can easily, quickly detect the problems and we don't have to switch between the tools and see what is affecting the performance and stability of an IT systems so that we can spend more time in innovating rather than finding where the problem is. So in this session, we are going to talk about the open source tool like Open Telemetry and also using the Grafana stack. How can we achieve this unified observability? Okay, let's dive into what this unified observability, how can we achieve? Quick introduction about me. I am Bagavathiappan. I'm a co-founder of Guha Tech, where we provide SRE as a service. I also have a 20 years of IT experience where I performed various roles, architecture, consulting, performance engineering, set up SRE landscape at SRE team for big enterprises. Also, I've got the patent in risk management, risk assessment with respect to reliability and change management. Also, one more patent filed. I'm also an active speaker in the Listeners Chaos Con, so also contribute to the open source community as well. Okay, let's directly get into the evaluation of observability. So we talk about monitoring in the earlier days, but now we started talking about observability. The first version of observability is like foundation for all modern application development. And this really helps to understand the system behavior. When we write a code, we have an infrastructure, there are middleware components in it. So this really helps us to gain some visibility into the IT infrastructure and the application as well. So what are the characteristics and the components like metrics is one of the key aspect of observability 1.0, where metrics is like mostly a time series data. For example, like a latency, throughput, or error, or even the backend system or infrastructure, CPU, resource utilization, memory, disk, and so on and so forth. And traces, this really helps us to troubleshoot any of these latency or error problems. Call tree kind of view, where when they're in the runtime, when there is a transaction or an API or a task getting executed, what are the different methods and the different services? What are the things being actually called? And where, how much time it took, how many times being called? So this really helps to capture those information. And logs, it's a traditional way where both system level logs or application level logs, where whatever the information we want to share to the analyzer, so whatever the information that system is facing at this point, it could be informational troubleshooting purposes or error or fatal. The profiling, this is also getting added as one of the signals in observability. Earlier days, this was not is one of this is only for applicable for lower environments, for non-production environments, where the sampling is very higher, so it's gonna affect the performance of the system if we run in production scale. But as soon as that after the Google's Dapper algorithm came in, our team actually found a really how can we do it in a lightweight and for a production scale system. So this is like advanced level of tracing. This actually provide minute level of information in terms of CPU, how the memory blocks are getting allocated from which line of code. So this really helps to solve a lot of memory leak problems. So in the recent observability teams, we see a continuous profiling with eBPF coming in. It captures all the kernel level statistics, what are the things getting executed, and that really helps to troubleshoot code level problems. Drill user monitoring. So just to understand instead of a synthetic, so just how the actual users are facing how their experiences are while using the system. So this really helps to understand the user behavior and experience. And application performance management, this is there for a while, so which provides capability of all these other things we saw, but this also play a vital role in getting the runtime. Apart from these, getting runtime visibility, if it's a Java application, how the Java heap utilization is, how many threads are there, connection pooling and all. If it's a Golang application, how many subroutines are spun, but how the Golang memory is being used. So it gives more visibility apart from these. So now you can think about we have all the relevant signals or capabilities in observability 1.0, but are we in this right path? Are we using observability 1.0? Let's see what are the characteristics of this. So we talked about all these things, but the challenge here is that it's all siloed tools. So we have to have multiple tools to measure individual characteristics like metrics. We have to use separate tools, for example, like Prometheus, collector, or specific agent which collects metrics and so on and so forth. Traces like open tracing or open telemetry, just to collect our Jaeger or Zipkin, just to collect the traces alone and inject it to the backend. And the logs, any framework which actually helps to gather the logs and events. Profiling, any again separate tools or separate instrumentation. Tail user monitoring, again like Bootstrap for any JS application or any other instrumentation or agentic base to collect the real user monitoring and the APM as well. So these are mostly silos. Some of them are clubbed together to get the unified view. And mostly it's a reactive approach. So we usually capture these after the fact of some other incident or issues already started, and limited and no correlation. So that's a gap of this observability 1.0. And it leads a lot of manual analysis because of the silo tool. So you have to look multiple tools to do a correlation and find out where the problem is. So now get into deeper. Silo data, we saw about it. It's really data silos, really the hindering of holistic view. So we cannot get an end-to-end picture even in the traces if you're not collecting the data from across the system. So it will still, the manual correlation needs to be done. And the limited insights. So even if we don't instrument any one of the component in the layer, so we'll not get a complete end-to-end visibility. So then if there is any problem happens, it's hard to troubleshoot. It's a black box. So that's when the Observability 2.0 was born, where it really helps to elevate the insights in the digital ecosystem. So when there is a system with like thousands of microservices, really helps to understand where exactly the problem is and how to troubleshoot and fix it. Where whatever the signals are, what are the characteristics of Observability 2.0, but it brings more context to the traces, where it gives so where this request is originated from. So where we'll have a parent-child relationship and adds more attributes or dimensions to those executions. So it really helps to find out if you want to get a trace of this particular user or this particular order, it'll be easy. The context really helps to find out or drill down those levels. And events. So logs, mostly it's like unstructured unless otherwise we follow some templates. Like we have access logs, have the Apache format. And but in the backend, most of the container logs, unless otherwise we enforce it, it's going to be like unformatted. So that's when the events really helps to do a key value pair with the formatted structure of data. When there is a critical events or change in the system happening, really helps to correlate the issues. Next level to the real user monitoring, the user experience monitoring. So this really helps to understand as soon as we receive the data, the UI receives the data. So how much time it takes to render the frame and how much time it takes for each of those activity that UI is doing. So what is the real user experience is when they do the action, when the app start time, app crashes, any unhandled exceptions. And the data stream, this is another important with the recent AI and ML world where we deal with like terabytes and petabytes of data, and also with Kafka streams and all with a lot of events processing through, especially in the IoT kind of systems, where how can we get deep insights and visibility into it? So this really gives a separate perspective with that. And business metrics, this is another important. So other than user experience, we also need to measure, get the business insights to it so we can make some data-driven decisions. So like how many orders being made, how like if the user is coming and viewing the product, but what is his conversion rate? So whether he's going to do a checkout and make a price like order to dollar, how much time and how much percentage of users getting converted. So those kind of critical metrics. So if there is any dropouts and what is the reason for it, if there is any technical reason or is it something else. So this really helps to gain those insights. And alerts in the traditional way, we mostly set a threshold based, which is not scalable and it's in a dynamic environment. So sometimes you tend to miss some of these gaps, especially when the business metrics and all. So that's where the composite alarm really helps to avoid this alert fatigue and reduce the alerts to noise ratio. So really combine those when there is an incident happen. So if multiple layers are failing, so we're not gonna have multiple alerts. It's gonna combine and have a single alarm, and really helps to focus the problem. So with this, what are we gaining? The characteristics of 2.0 really helps us to provide a single source of truth. Obviously, with the context and formatted events, we can quickly troubleshoot or filter out only what we need. And really, with the open telemetry and open standards and the agents, we really have low code or no code instrumentation to get the data. We'll see what are those instrumentation types, how to do it. And also open standards and interoperability really helps to have a kind of no vendor lock-in situation. And it's a cloud agnostic where it'll really support both on-premise or hybrid or cloud native environments. And the observability funnel I just touched upon a little earlier. So when there is any digital ecosystem, digital IT application runs on any underlying infrastructure or platform, the observability really helps to capture the capacity utilization and saturation level. So this is the very foundation where all the code gets executed in binaries. And on top of it, we'll have all these downstream systems where data resides, where we need to capture durability, consistency, integrity, and also recovery aspects if you want to have a high availability solution, scalable solution. On top of it, we'll have a connector layer, middleware layer, which actually needs to propagate the context and also provides the resilience view, how the health of the downstream. Do we have a right circuit breaker or a fallback retries pattern? So this really helps to get that perspective of it, health of the backend downstream systems. On top of connector actual origin of these business logic and API calls, we mostly measure the golden signals, the latency, throughput, error rate, and saturation level. And real actual API consumers from the website or an app side, so where it'll have get the customer journey map. So what are the different activity customers are doing so that we can get real actions happening in the app in terms of business usage and also what users are seeing. And apart from all these technical stuff, on top of it, the funnel, we have a business metrics where we'll get clear visibility into the business functions and what are the outcomes. So the idea for this funnel is when there is a drop in the business or when the users complaining about some other things not working or not working as expected, then we need to correlate to any one of these technical layers. So that is the intention of this funnel. So to have a mostly composite metrics or alarms and also to gain visibility of business interruptions due to any technical failures or technical challenges. So this will definitely help us to have a reliable, resilient, scalable, and secure platform. So now let's get into how can we achieve this single source of truth. The reference observability architecture, I would say, where we have the target IT system will instrument using the no code, low code engines or the SDKs, which sends the telemetry signals to the data collector in the periodic interval. So the data collector will receives and converts and sends it to the data pipeline, where this is where actual data massaging happens, where pipeline not only combines data, add relevant additional context to it, which cluster it is running on, and additional masking if there is any sensitive PII information is there, we want to mask it and convert it into any other format where the data lake accepts any common format, like it doesn't accept key values there, it's a column store, columnar store, or it's a time series store. If you want to split that, or if you want to convert that, it will also happen in the pipeline side. Once the data getting converted and it's ready to store, then it will be pumped into enterprise telemetry data lake. So this is where all the telemetry signals come and stored in a single source of truth. That's where we'll not have a different perspective, different time zones, all these problems that we usually face earlier. We'll have all the signals like metrics, traces, logs, events, profiling, event profiling data, and also all the front-end business insights data, user experience data. So this really helps us to visualize, so we can get a single pane of view. Not only that, but also helps us to create a composite alarms if there is any standard deviation or anomaly detected. Really helps us to correlate where the issue happens, and also really helps to run those synthetics to make sure you try to capture if even user sees it. So if there any chance to capture it earlier, and also helps us to define the SLO thresholds, and also helps to track those SLOs. And not only that, it also helps to make a data-driven decisions, or since the data is in a single place, it really helps to run these ML or foundation models to understand the data and really helps to solve the problems. Now let's talk about open telemetry. It's an open standard, and it is, as everyone knows, the second biggest project in CNCF. How does it really help us to get the unified view? So this is cloud native and really helps to avoid any vendor locking situation. So once for all instrumented, so wherever we want to store the data, it really supports it. And it supports 20 different languages for all the four different signals. They provide what is the latest state of the individual programming languages. And instrumentation is where it's really key, where we talk about low code and no code instrumentation. So OpenTelemetry supports most of the language, commonly used languages like Golang, Java, or Python with auto instrumentation. But one challenge is auto instrumentation really provides us all the coverage for all the HTTP modules or any other gRPC based any calls that it makes between the services. So it really helps to auto capture these information like metrics, traces, and logs. But if you want to have a business insights or business metrics or business events, so that's where we have to touch a code a little bit, add an SDK way of having things, get some custom metrics added to your trace and the spans. So then we need to have additional lines of code in there. So otherwise, it really supports the low code. Just simply throw a couple of lines of configurations and bring the binary into a module, and it automatically captures this. Typically, it's like an agent-based instrumentation, how these traditional APM tools work, but the code is really going to give more granular level details and additional information. So once we instrument, the next step is to collect and correlating the data. So this open telemetry agents really collect the telemetry and send it to the open telemetry collectors, where it actually helps to all process the data and store it into a data lake. Then the correlation really happens by leveraging all the metrics. So when there is a high latency span observed, then we can really give a correlation of what is the actual service resource utilization at that time. What was the services latencies during that time? Is it only for this particular request or it was already performing poor? What was the error rate? So it really helps us to give the contextualized view for a single pane and really provide unified view of the system behavior. And with the help of this context with the custom attributes, we can even really filter the traces or spans specific to that particular custom attribute. Maybe it's a customer email or customer ID or order ID, or whatever the business attribute is. And once you have all these data coming in, the correlation done, so it really helps to visualize the traces, metrics, and logs in Grafana. Grafana is a wonderful visualization tool. A lot of the pre-built dashboards are there. So it really provides us a single pane view of all traces, metrics, logs, and profiles as well. So it also give an interactive exploration where if you want to drill down further, so you see a specific anomaly there. So it really helps us to further drill down. It provides hyperlinks to other views and dashboard, and also helps to build a custom dashboard. There are plenty of dashboards available in JSON format, so we don't have to build new one, especially for common technologies like Kafka or Kubernetes or any cloud-specific services. So a lot of things that are there, especially for a Linux. I've seen this very big dashboard which covers entire Linux stack. So it's really useful. So it's ever growing. So that it definitely provide a contextual, unified, single pane view. And Grafana also growing. They've had a lot of other stacks as well. So this is the complete Grafana observability stack, where it collects through the agents through like a Prometheus exporter for any metrics or OpenTelemetry or a Fluent build. It collects into the OpenTelemetry collector, their own OpenTelemetry collector, and also stores it into the LGTM stack, the Loki for logs, Grafana for visualization, Tempo for traces, and Mimir for metrics. And also it provides a continuous profiling through Pyroscope. So once we have all these data stored in these data lakes, we definitely will have a complete visibility. So we'll have application observability with the front ends and also calculate the service maps, provide service map views through the traces, and also give EVPF perspective for how the profiling happens and what are the hotspots there, and provide infrastructure observability to follow Kubernetes from the server VMs or databases or any cloud native integrations as well. And it really helps to have a incident management in terms of providing alerting capability, on-call support, and for incident tracking, and also even the service level objectives. So apart from this, if to shift left and really the K6 really helps us to simulate the load in terms of backend as well as for the browser testing. So definitely it's a unified single place to go for this observability stack. And it also integrates with a lot of other big data sources. So once the collection layer is there, if we don't want to manage these data, we can really ship to all the commercial products out there. So now the empowering alerting and incident response. So this alerting is very key there for timely incident response. So this really helps us to the composite alerts really helps us to have a rules based and multiple data sources combining into a single alerting system so that it really helps us to avoid these alerts to noise ratio. And also it really helps us to automate root cause analysis. So the integrations with webhooks really helps us to trigger a workflow where it can go and look at based on the knowledge graphs and the service maps to find out in the ecosystem or in the chain of events what exactly gone wrong, what is the anomalies or correlation, and provide the RCA as soon as possible. So with these observability 2.0, what is the feature of observability? So definitely to accelerate the innovation where the time to detect and time to isolate and time to recover is going to be shorter and shorter with these tools. Definitely it really helps to accelerate the innovation. The unified observability, definitely the single source of truth is going to empower to make the data-driven decisions. And intelligent automation, this really with the evolution of AI, agentic frameworks and AI and machine learning, really helps to detect the anomaly and trigger a workflow for a quick auto RCA and even do the runbook automation or having a self-healing system built, it auto recovers itself. And also, let's not forget about the security aspect. So it really helps to analyze those audit trails and events to have a security threats and vulnerabilities by detecting the behavior and pattern analysis and really helps us to find any security threats and vulnerabilities there. With that, hope you've learned something today. Thanks so much for joining us. And if you have any follow-up questions and feedback, please connect me over LinkedIn. And thank you so much and have a good rest of your day.